That's not it. Yeah, whatever. Yeah, nonsense. How do they call it? Setup. Right. Alt top. Therefore, I want to change something in CoordinateSystem.h. Namely, I need music. Yep. In display, draws the coordinate system. You know, this is a template class coordinate system, and display displays it, which it does by running over the two axes that we have, the x-axis and the y-axis in this loop, and that's the end of the function. So we draw one axis and then we draw the other axis. Yay! Inside the loop, it's possible that the axis is entirely outside of the window, so we don't have to draw anything. Normally the origin is inside the window, but if it is not, then of course at least one axis is not visible, maybe even both. Okay, so for the given axis, this draws the piece of the axis that is visible. You know, like the axis runs like diagonally like this. We have the point where it intersects the rectangle of the window and the other one here, and it can draw a line. However, that means that apparently we calculated that already, because we have a line piece here that well represents that piece, that segment of the axis that is visible. That was initialized here in the constructor, where we test the constructor of the coordinate system. And this has also a loop over both axes. And it calculates intersection points. Intersections, that is intersection between a line and a rectangle, where the rectangle is the outer enclosure, how do you call that, of the window, just the whole window size. So from 0, 0, which is the top left, to window width, window height, which is all the way down here in the bottom right. And the line, well, the line is an infinitely long line, exactly, well, being the axis that we look at that moment. That is defined by my guess would be that this is the coordinate system axis. Direction. Which axis? This axis. So there's an array. And direction is just, you know, well, a little what it says, a direction, but I store it as an unit vector that points in the direction that I want to store. So probably, you know, this is a vector like 0, 1 or 1, 0, where 0, 1 is then pointing in the positive x direction, or we get 1, 0 pointing in the positive y direction. And thus, if we take the negative y coordinate of that, for the x-axis, the y is 0, so then this would be 0, and the y-coordinate would be 1, which means that if the x-axis is horizontal, and then we have a unit vector that points up, and it's called normal, so that is a direction that is normal to the axis. Yeah, something that points along in the direction of the positive x-axis, and we rotate that 90 degrees, and then you get the normal. For the y-axis, well, the y-axis is vertical, and I would say that has to be done in the same way. So we have a unit vector pointing in the positive y direction. Well, the positive y direction in Qt or in widgets or in the window all have the positive y-axis down, so let's work like that as well. So there's a negative x-axis, positive x-axis in that direction, so a unit vector in that direction. And then we have to rotate that counterclockwise in this, oh boy, yeah, well, but you know, it's upside down. So the x-axis will rotate 90 degrees counterclockwise, and then we point in the positive y direction, so it still ends up as 0, 1. And the y direction then counterclockwise should point to -1, 0. Yeah, and that it will, because here's the minus, and this is then 1, and the x is now 0. So this is the x coordinate of the normal, this is the y coordinate of the normal. And then we create a line. It's called a line, but it's actually a hyperplane. We should look at the hyperplane. Vector, float type. An n-1 dimensional hyperplane. Orthogonal orthogonal to a given normal vector n with offset dn from the origin. Okay, so you feed it a normal and then that dimension is collapsed. So in this case we have just a two-dimensional plane, which means that if you give it a normal, then the remaining part is just a line, because the part orthogonal to the given normal vector is again just a line. Yeah. So that this represents indeed the axis itself then, because we feed it a normal. And what this is, I don't know, D. Oh, that's a distance thing. Create a hyperplane that satisfies the dot product of the normal with x plus d equals 0. I think I'm just going to ignore this implementation. Yes, I wrote it. No, I have no idea what it is about. This thing just represents the axis, period. And then we calculate the intersection between the axis and the rectangle. That is the window, the outside of the window. Those intersections, if there are no intersections, then the origin is outside the window apparently, and this axis is not visible at all. Otherwise, we get both intersections, because then there are two, and we store that as a line piece in line piece. Now I want to take a step back and look at this as how can I write a function that I feed sensible data and then it spits out those intersection points, or maybe just a line piece. Yeah, I don't know. A line piece is just 2 points, so either I give 2 points back or I give 2 points back wrapped as a line piece. It doesn't really matter. It would help though if I knew which intersection is what. I think I could feed it this direction. So let's say we have an axis like this, and the positive direction of this axis is in that direction. Then going in that direction we get an intersection, and going in the opposite direction we get another intersection. Then I want to know which is which. Now the line piece is formulated in terms of 2 points called from and to. So let's say from is here, and then going into the positive direction we get an intersection here, and we call that one 2. Do I want to write a function that I feed a direction and a rectangle? Yep, not a rectangle. I could posit a rectangle, and then copy that into my hyperblock internally. It kind of depends on the type of this. No, just some math coordinates, I think. So just the direction. I don't even have a direction with a link to a coordinate system. So the coordinate system here is determined by the context, unfortunately, because I'm too lazy to make to duplicate basically every class in the math namespace, just to tag it with a template parameter that tells us what the coordinate system is that we work in. This one is in pixels. Yeah, I guess it doesn't really matter for a direction, although a direction is supposed to be a unit vector, but a direction is... Oh, no, that definitely totally makes a difference, of course. The pixels coordinate system and this coordinate system can be rotated relative to each other. So if you would confuse the direction, then yeah, and after rotation, the direction would be different. So you have to be aware that this direction is in pixels, in the pixels coordinate system. But my function does not necessarily have to be aware, or has to be aware. Yeah, not necessarily has to be aware of which coordinate system it is working with. You can just feed it a direction and a rectangle. This also does not support coordinate system, it's just double. So you could posit a math rectangle. So how is the hyperblock storing its stuff? Let me see. Hyperblock. That's an array of vector type. So in our case, n is 2 dimensions. So we have 4 corners. One shifted left twice is 4. So vector type, that is, well, a vector. That would be a math vector, I think. No, this is in cairowindow. But it's probably still a math vector. Namespace. Namespace intersections. Oops, totally not. It's a special vector. The intersections vector, which is an array. Yeah, the number of dimensions is variable here. This vector can be constructed from an initializer list. Okay, that gets a bit complicated, too complicated, I must say. So this is an initializer list. I don't really want to do that from, let's say, a math rectangle. Let's just construct a rectangle as this type, although it's like a really weird rectangle. Intersections hyperblock. Okay, so we can move this one up. And then want to end up with a line piece. That would be this line piece. So then we get the function, and then we get the line piece. And we have intermediate stuff like the normal x, but I guess that normal x is not used outside this block. Nope. No, normal y also not. And the line is also not used outside of it. Line piece, of course, but not line. And then we have the rectangle. No, it's not used at all. Well, it's defined here, but and then used here. Okay, yes, but it's not used after this function. Although it even could, because I define it here, so why not? I was mistaken. It's not a new local variable here. Intersections is, so I should have looked at that one. Intersections is also not used after this line. And then the next one is P1 and P2. Oh, those are being used. Those are being used here. Well, if that's the case, then maybe I should return P1 and P2 instead of a line piece. Otherwise, I would have to take apart the line piece again, which is of course totally possible. I'll only need it here, right? It is kind of annoying that a point can only be constructed from an x and a y coordinate. It would have been way easier if we could construct this thing from a math point, which we are going to have. I think I did not want to do that because every point with a coordinate system tag is derived from a math point. So if you can construct a point for a given coordinate system from a math point, then you can just copy a point from one coordinate system to another. And that would totally not be thread safe, of course. Thread safe. Type safe. But then go to the point. I have a lot of points. Math point, source point, this one. So currently you only have a default constructor, which is just the origin in the current coordinate system, and you can construct it from an x and a y. You cannot construct it from a math point. Now I used a trick already, and I added it here as well. Yeah, I used a trick in the line, I was going to say, and I even added it here. So a trick is to use an R-value reference to a math point. I mean, cairowindow point is the same as a math point. I'm not sure anymore, but I think that that's exactly the same. Yeah, cairowindow point is just a math point. So we can copy an a math point. We can construct a point of some coordinate system from a math point if that math point is a temporary. But it's just tiny little bit less error prone, I guess. I mean, a temporary this would accept a temporary, which are our value, our values. So yeah, this accepts our values. Well, it's here already. For some reason I decided that I need it anyway. Well, wait a minute. It does say this constructor should never be called manually, i.e. by using standard move. I was so going to do that. Allow returning in cairowindow point by value from a function that returns a point CS. Okay, so that means we need a function that returns a point CS. And then this comment gives us permission to do a return some variable, but that variable is a math point. That will then use that. But that doesn't help us, or does it? Actually, it does help us, because we just... That just means that I want these points to be returned by our function, directly the point CS. Which in turn then means that we don't have the line piece. So our function is going to return these 2 points, but I need a line piece eventually. Oh, that's kind of strange, because this one is already converted. This one is converted from pixels to CS. Yeah, so I'm wrong. We must return this. A point in pixels coordinates. And that is then to be constructed from a math point at the moment it is returned by the function that we're going to write. Which still means that we get yeah, I need points. Okay, let's say either that, or I need a line piece that is coordinate system aware. Maybe it should start with that. Then we would have a line piece that's coordinate system aware, but that's not that much of a problem, because we can just use that here. I think that's also the only place where it is being used. Okay, I think I'm just going to return to point CS pixel point. So our function will do something like auto. Let's call them just literally to and from. Is, and then the function name, no, intersection, intersect. And then we pass a direction, the axis, and we pass the rectangle. where then to and from are in pixels. In a minute, I'll do that the other way around. Let's from to. And then we make, well, I can just pass, I think that for this line piece it doesn't really matter which one is which, so I just pass from pixels, 2 pixels here. Because point is derived from math point, and line piece, math line piece takes a math point, but the pixel CS, sorry, point CS is going to be derived from a math point. So if you try to pass this, then it will work as well. And here we already have these now. These are just going to be returned as pixel. And then, oh, wait a minute, yeah. Extract the minimum and maximum values of the visible range. You don't really know if P1 is the one on the left or right. Trying to wrap my head around this. Min, max, min, max, min, max. Oh, well, right. Yeah, okay. So these values are supposed to be the coordinate system values on the axis where it intersects the rectangle of the window. And then min must be the smaller value. But if this is the axis and the direction of the axis is from here to there, then from is the minimum value, obviously, because, well, that is the positive direction. Therefore, instead of calling it min, you can now call it from and to. Or I can just call it min and max anyway. And I don't think we need this anymore, or rather we need it, but it should be already the case. So I'm gonna assert here that min is indeed less than max. And that then is the case because we are using here from, and here we use to CS. From is per definition, if this is the x-axis, then from CSX is per definition less than the 2CS for the x, and if it is the other one, then of course it's for the y. This is 2 then. This x or y. So now I can call these respectively from and to. And then that is a conversion simply from pixels times pixels transform CS. Then we go from pixels to CS. Like I said, like every stream, there's short circuits. That is deleted as well. So from CS is from CS. And here we have another conversion to pixels. And then let's print those, or let's print them under that name. Great. Well, still need to write the function, huh? So we need an intersect function that takes these two, does this calculation, and returns the result as a tuple of points, yes. So it must be template function. Template CSCS standard tuple point CS point CS intersect it was stuff return the tuple and what did we pass again? This. Yeah, this is in pixels, so that is, but I didn't have a direction yet, and I still don't have a direction yet. I think that is coordinate system aware. Just half as work. Math direction. Nope, it's not there. Oh well, okay, so just the math direction. And the other one is then also not CS aware actually. Well, that makes it kind of hard to convert it. Well, we can just pass. We have to pass it. I think. I mean, these two are normally you would say, yeah, damn it, I should just add that. You know, like I should add a direction CS. So it infers the CS value from whatever, from the direction that you pass. Am I going to be lazy or not? That is the question. It's there's another. I'm not really writing a library. Otherwise, I would definitely do that. It's just some intermediate playground stuff. I don't know. Let me be lazy for now. Just make this work. So we can just call wherever the intersection is called. What the hell? Intersect. It's not intersection. Intersect. So I just tell it here that we want pixels back. So by passing pixels here, it will return pixels, but that also means that we must guarantee that that and that are both in pixels. And we can't verify that, so this is not type safe. But hey, we can tag it. This is tag it in the variable name itself. Rectangle pixels. The rectangle is in pixels. My CS axis direction is in pixels. Maybe should tag that as well, but let's not right now because it says in the comment already that it is pixels. So I'm done with this. Intersect. Okay. It is called intersect. Oh yeah, I was looking for the type of the second argument. That is strange. Intersect. That's I thought that's how it was called. Oh no, it's no it's yeah, okay, never mind. So the type is that one, second argument, which is this. I'm still going to call that rectangle. Now here I would have to call that rectangle CS and not pixel, because this CS is not the same as that CS. Is that confusing? This is a free function and this is the template of the class. I'm going to put an anonymous namespace around it, I think. Just to make clear that this is I could maybe could, you know, detail or something, as in don't touch this. I got to. How is you? We should not pass that. We should pass the whole thing with the axis and all. Then that's an array. That won't work. Pass the direction of axis. And pass const rectangle. Where did we detect again that there was no intersection at all? Because that's no longer being detected here, it seems. Oops, there's a continue in the middle. I think I have to take care of that as well then. Shall I just throw an exception? Oh, nah. I don't throw exceptions for stuff like that. Or do we? Kotero, what do you think? This tries to calculate the intersection. It intersects whatever a line and a rectangle. That gives us 0 or 2 points. Could make it the standard optional maybe. Yeah. Can I still use this notation if it is a standard optional? Probably not. So you can use this notation if you just return a standard tuple. But if it doesn't find anything, then there is nothing to return. 1 point? Yeah, well, I count that as 0 points, actually, because 0 points means don't draw the axis, and if I have only 1 point, then I'm happy with not drawing anything. Yeah, I understood that, but then you don't have to draw the axis either. It hardly makes a difference if it is outside it or just touching the corner. In fact, I would just get 2 points, I think, which are the same. So what I could do is pass 2 points which are the same, and then detect that there are no points by checking that these two are the same. Yeah, I think that will do. Let's use this. Oh, well, no, not particularly, because this is not run in a loop of 100,000 long. It's anything is fast enough. I just like this notation so much. I could return a vector, test if it has a size of 2, and then if it does, yeah, put from in index 0 and 2 in index 1. Yeah, maybe better. Maybe better than doing this. It's kind of dirty, isn't it? Okay, I'll use a vector. So instead of 2, we get intersections. Intersection is a namespace. It's not going to work, I'm afraid. No, not empty. I'm gonna do size then. If I get really, I mean, less than 2. If it can return 1 point, then I'm going to ignore it as well. I kind of hate auto in this case. I mean, I know what the type is, might as well type it. Standard vector of points, yes, pixels. Yeah, I thought about that, but I hated that as well. I don't really like passing output variables as a reference or even a pointer. But definitely a possibility. Yep. Yeah, if you see this shit, I might as well initialize these and then pass them by reference. Or use an array. Man, there are so many different ways that you can do this. You want to return that then? Yeah, also possible. You know what? I will. So in advance we have to declare the output array. No, we don't. Mystery happens here. I don't want to do this if we can avoid it. I just want to keep it simpler. So we have from pixels here, and we have that only twice. So I have 2 pixels twice and from pixels twice. What about what would be a good name to use with an as an array? Normally I use this just to show that it is in pixels. Could leave that out now to make it shorter. So something like something from. What should something be so that you understand that this is the negative axis intersection. Maybe even from can be renamed if you want to. I could call this intersection with, and then rename from with a negative negative side of the axis. You can make it complete English. I'm going to use intersection point because it's a point. But I'm not happy with that. It doesn't tell me that it is in pixels. So let's just make it longer. I can't help it. Intersection point pixels from. Bah, okay, we got can leave it that, I think. And then this would be the same thing with 2. And then we have to repeat that here. Okay, so then what do we want to have returned? I want to have returned, and I could still use a tuple, I think. So auto number of intersection points, comma, intersection point pixels. How about that? Too dirty? Is this too? Are my variable names too long, or why? I mean, I would say why not? You know, it's at least it's clear. And now we don't need this. Just go straight for the array. Now this really should be part of the function, so I can move it into details. Yeah, it's random. I mean, we have the negative side of the axis. First? What do you mean first? I mean, the axis has a negative side and a positive side. The x-axis has a positive side and a negative side. That's how they are called. The axis is oriented, yeah, and in that it has a random orientation. It's rotated. No, it's not necessarily intersecting at a negative point. It's just the direction. So going from the point from to the point to is going into the positive direction. From -5 to -3. Then -5 would be from and -3 would be to. Could also be -5 and plus 15. It could also be 10 and 15. I code. Yeah, maybe it's more mathematics. I don't know. What do you mean what is on the screen? That C++. Yeah, but I don't like any integer or any literal to be hard-coded more than once. So I have it here, from, and I have a from here. And again, now I know that 0 is the negative side, but in a week I won't. So now at least I know that both these froms are this, and I can read the documentation. And then I see, oh, this is the negative side of the axis. The only other option would be to delete the comment and call it the negative side towards the negative side of the, but that's long. No, I disagree with that. This definitely has to be some cons expression which you then use. I think from and to is pretty descriptive. Usually you go from the negative side towards the positive side. This is C++. Okay, so no, this is then your thing, as in, well, I don't do size types because they are unsigned, I mean. I'm just gonna do an int here. An int and an array size 2. Okay, we have nonsense again. I can't have an intersection with just the direction. Ugh. Must be a line. Nope, this is new Vim. S index, I guess. Yeah, like I said, you can't use the direction. I mean, just the direction is not enough to know where it intersects. So you have to change that into a line. Interesting enough, I did add a line. So if we're going to pass a line here, let's just pass a line CS. Then it can induce, what is it? What is the word? Infer. And it can infer the template parameter from the type that you pass here. Okay, well, before I implement it, let's make sure that we pass something that makes sense. So I no longer have to pass a template parameter, but here we need to pass a line. Now that's confusing. Let's just call this line for now. Line pixels. You know, I get more and more code that used to be here, still here. I want to put as much of this stuff in that function. How do I make a line in pixels? That uses the cairowindow line constructor, which is, this is plot. That is just the math line. This is draw line. This is math line. And the constructor takes a point and a direction. Now the direction I have, I think, in pixels. So point, comma, direction. Oh, see, that is just this one, the origin. So this is the origin in pixels. That then now the line goes through that point, and then the direction is the direction of the axis. I don't know how to say this. Instead of points, you can return values of parameters used in line equation. Yeah, well, I'm just using the line class that I already have. I don't want to redesign my math library. Yeah, mine does. My lines have directions. Don't you hate it? That's how I define a line. Go on. I think I even have different styles for how to draw the line. So you can draw this line and you just get a line, but you can also draw it and then change the style into a half line. And then it draws a half line. And then the direction really is important. Okay, I'm still thinking about how I can make this shorter. One way would be to just pass this directly to the function. So you pass the origin, the direction that the axis goes into, and you can also pass these directly. So at least then I got rid of this type. Or then did not. I still have to pass the CS pixels then. No. But this is just an annoying type to have to construct. On the other hand, I think it just literally takes this type in the function. Like there. Could pass it by value even. And then just construct it. As in, hey, it's by value. Hint, hint. Same thing goes for the line. I think I'm just I'm gonna do that. I'm like, yeah. This thing needs a construction at the moment that you call it. because yeah, we don't use align pixels anywhere else. It's just a one-time thing here. And the same for rectangle pixels. So I might as well pass that. I think that's about it. Now to fix this function. So this part is now just my lines, yes. And then I create a hyperplane line. Yeah, wait a minute. This was the direction, huh? Oh, yeah, that was the direction. So he created the direction from the CS axis direction. So this normal is the direction of my line, aka line dot direction dot y. Because line returns the direction and I constructed it with the thing that we actually want to use. And then here we have the origin in pixels, which is now, if we go back to the line, this point. And that point you can get by calling point. So this is really a point of the line. The lines, yes. Arg, I'm still doing this. I might as well have done that from the beginning then. I mean, returning twice the origin, period. But yeah, in this case, now we have this. I have to return 0 and some array. Do I have to return an array at all? Can I not just return this? So probably going to default construct array, but nobody's gonna look at it. This we can't even do here. So that then still has to be moved to the caller. Yeah, that would work. I'm just wondering if I can't leave it out. I suppose you can't, right? Because it's a tuple. But on the other hand, it's an initialized list. I give you most chance, but I want to try it. There's nothing. Yeah, that's kind of scary. Are you sure that is guaranteed to put my int to 0? In this case, so normally I use this when I want to have something initialized by the value. I don't really care about the value. In this case, the 0 is significant. It does have a meaning. It means that there are 0 intersection points. So, following my own style, I have to mention the 0. Even though without the 0 it would still result in the same assembly. So you get that 2 points where these CS axes intersect with intersects or intersects? Intersects the window rectangle. What I don't know. Oh yeah, this is a separate function. We don't know that we're talking about the CS axis. At the point where the line CS intersects with the rectangle, and it's definitely not in pixels. Well, it is, but this gives us math points. And now the annoying part comes there. At this point, I don't know which is which. I have no idea which intersection here is the one that belongs to the negative side of the axis. Also, I'm so not interested in... Oh, wait a minute. It's either empty or it's... I mean, I don't do 1 point. It's just going to be 0 or 2. Even if the points are the same. If the points are the same, then... I don't know. In other words, here I'm going to return 2, comma, and then we have to initialize the array with a from and a to. Which I doubt will work. Probably need 2 braces. I think we need 2 braces. Let's begin with 2 braces. But I still don't have my from and to. I don't know which is which. Do I really not know that? get intersection points. Intersection points return hyperblocks. What does it? No, it returns a vector type of the hyperblock. But maybe that vector stores something. Float type. Vector. Slightly confused here. If n is 3, for example, then this is a plane, and the block is a 3-dimensional block. And if you intersect that, I don't get points. I get a load of lines. Get up to 6 lines even, I think, in that case. This just calculates a single, well, an intersection with a line. Then you get points. Right. So the hyperblock is just something that is an actual block in 3 dimensions. I mean, like a cube, but then different sides length. Although the angles are everywhere 90 degrees. So yeah, that's what you call a block. And we work with 2 dimensions, so we might as well think about that to make it not too complex, although this class will work in any number of dimensions. So in 2 dimensions, the block is a rectangle. And in that case, the number of corners is 4. And n, the number of dimensions, is 2. So n is 2, and the number of corners is 2 to the power n, defined here. 1 shift left, and that is 2 to the power n. So we have 4 sides. It doesn't feel right. Let me think. What is this called? Side? No. Side. Sorry, side is the Boolean, of course. We have a number of corners. I'm sneakily think about in 3-dimension case. So a real block would have 8 corners. Don't really see the... So if you have a 3-dimensional block and you cross it with a plane, it just calculates... oh yeah, of course. I'm sorry. This runs over all the corners, and then it determines on which side the corner is of the plane. And that's why it's called a hyperplane. If you are in 3 dimensions, it is an actual plane. But if you are in many dimensions, then it's just a thing that is 1 dimension less. So it's determined by the normal vector on it. So this determines if the normal vector is pointing to the side where this corner is, or if the corner is on the other side. So in case of the line, and I mean, if you have a square like this and you draw a line through it, then a number of corners are going to be on this side of the line, and a number of corners are going to be on that side of the line, where the side is then determined by the normal that defines the line. So there is a vector that is perpendicular to the line. If that vector points in that direction, then this is one. Then this is the side that is whatever, and this is the other side. So away from the normal, or on the half of where the normal points to. And then we run again over all the corners. And this time D runs over all the dimensions, the number of dimensions, because each corner is connected to n dimensions, n other corners. And you can find them by shifting the D. Shifting 1 D. And then doing this trick. So this runs, the CI2 runs over the indexes of all connected corners. And then if the 2 corners are on opposite side of the hyperplane, and then the line, and that is then an actual line, from that one corner to the other corner must pass through the hyperplane. And then I would still get not a point, to be honest. If the hyperplane is three-dimensional, for example, I would get a line. Yeah, I don't know. Let's not concern ourselves with that. So in this case, you have a square run over 4 corners, 2 dimensions, meaning the 2 connected corners. So this 4 times 2 is 8 possibilities, which means that we take we get CI and CI2 swapped as well. Yeah. Pretty sure we get every intersection twice, right? So how does that work? But yeah, the order in which our intersections are pushed to this vector is very, very, very arbitrary. We just run over corners, which are encoded willy-nilly. Really puzzled about duplication here. Hi, AU. Oh my god, it's late. I have to go to bed. It's almost 3 a.m. as it were. I mean, I want to go to bed at the latest at 2 a.m. Now I see it's 2:39. So I am late. That's what I am. And yeah, I don't know. Tomorrow another day. But I have 8 viewers, which is a lot. So I will give a bonus here and show you the output of my current program. Did I edit something? Oh yeah, I was working on this. Let's save it. You know, come on. Look what we have. Yep. It actually looks horrible. And I can't compile it anymore, of course. Git stash whatever. Let's edit this one. Let's not scale this. And let's... oh, I did have that. Look at that. We have not just tick marks, but also the numbers at the tick marks. And I can rotate this thing. So it now it decides where to put the tick marks with the function that I wrote in the previous stream and the day before that. I think it all looks very nice. So what I have been working on today and will continue tomorrow is that I want to add a little X and a little Y here. And then in red and in green as well. So this is the X-axis, the green one is easy. And I have a little X here on the positive side. And a little Y here, also on the positive side. On the opposite side of the tick marks. So here we have also a positive side. Well, this is in the positive quadrant. That's where the rectangle is drawn. And the long side is the X-axis. So there must be an X here and there must be a Y here. And I want them to not be rotated. I mean, not like these things that they face the view, that the bottom faces our window bottom. They just go around as they are, and even if they get upside down. And I am going to determine where they must be drawn by having a little inset to the window rectangle minus 10 pixels. So there is a rectangle here that is 10 pixels from the side, like this. Inside, 10 lines everywhere 10 pixels from the side of the window. And then I'm going to calculate the intersection with a line parallel to the axis, 10 pixels from the axis. So imagine a line here parallel to the red x-axis, but at a distance of 10 pixels. And the same thing here, 10 pixels away from the y-axis. And then we calculate the intersection between those lines and the inset rectangle. And then you get, for example, a point here. You know, this line crosses that line. And then we put the X here with the center of the X on top of that point. So there will be an X here. And here we get this line with that line, so there will be a Y here. That's what I was working on. And then that means that I need to calculate the intersection point here. Yeah, so we know that the line goes from here to there. Which is an intersection point between two lines and a rectangle. And now I need again two lines, which are 10 pixels next to the axis, and a rectangle. That's why I have been putting that in a function, because I know I need it twice. Okay, good night. I'll be back tomorrow.